welcome all to the next tutorial in Biostatistics about variance, which is a measure of dispersion. Variance is the measurement of spread between the numbers in a data set, and it measures how far each number in the set is from the mean, and therefore from every other number in the set, that is known as variance. It is a measure of spread. Now, variance is defined as the square of the standard deviation. In the previous tutorial, we learned about standard deviation, and standard deviation was square root of sigma d square by n. But variance is the square of standard deviation. Variance is equal to standard deviation square. Standard deviation is equal to square root of sigma d square by n. So variance is equal to square of sigma d square by n, that is equal to sigma d square by n. So simply variance is equal to sigma d square by n. Sigma d square by n is the equation for variance. Now let's see an example which is a ungrouped data, and here is a question which shows the length of 9 earthworms. And when you get this question, the first step what you have to do is, in the standard deviation we have explained how to do. First step is to make a table with 4 columns. 1, 2, 3, 4. 4 column table for variable, for x minus or variable minus arithmetic mean, then d or the deviation, and other column is for d square. So you have to, with this question given here, you have to substitute the values. The table or the completed table is given here, and you have to find the sigma d square. Sigma d square is equal to 60, and arithmetic mean has to be computed first to find the value of d. So arithmetic mean is equal to sigma x by n, that is equal to 20. And you have to find sigma d square, and the variance is equal to sigma d square. You have to substitute the value is equal to sigma d square by n, that is equal to 60 divided by 9, that comes to 6.67, and that is the variance for the question which was shown here. Now let's work out a question of grouped data. It is as simple. Then group data is the question is given here, which shows the weight of 50 fishes, and in this question we have first step what you have to do is make a table with 6 columns. Make a table with 2, 3, 4, 5, 6 columns which shows the variable. Then the next column which shows the frequency, because this is a grouped data, which shows the frequency, and the next column f into 6 or f into the variable. The next column is to find d. D is equal to the x, or d is equal to x minus variable minus arithmetic mean. Variable minus arithmetic mean is d. Then the next column for d square, and the next column for f d square. You have to substitute the values. The completed table is shown here, and you have to find sigma f d square, sigma f is equal to 50, sigma fx is equal to 231.1, and sigma fd square is equal to 101.74. And for computing the arithmetic mean, the equation which we use is sigma fx by sigma f, that is equal to 4.622. After finding the arithmetic mean, you have to find d square that d and f into d, find sigma fd square, and the final equation for variance is v is equal to sigma fd square divided by sigma f. Sigma fd square is 101.74 by sigma f is equal to 50. So the answer comes to 2.035. That is the variance for this grouped data. Now let's see a grouped continuous, how to solve a question which is grouped continuous series. And in this step, and I've always said, because this is having class interval, when you have the class interval, the only difference is you have to find the midpoint of that class. Class interval is given first. Keep in mind, you have to find the midpoint. So, a question is given here which shows the weight of 60 fishes, and the first step is to make a table with 6 columns. Make a table with 6 columns which shows class interval, and I said midpoint, that is the second column, midpoint. So here midpoint is x. Then next column is for the frequency. Then next is for f into x. The next column is for d, that is equal to d is equal to x minus x bar. Then next column for d square. The next column for fd square. And complete the table. Here you have to find sigma f. Sigma f is equal to 60. Then you have to find sigma fd square. Sigma fd square is equal to 130.198. 130.198. Then you have to find the before finding d, you have to find arithmetic mean, and arithmetic mean is equal to 4.23. And now substitute the values for finding variance. For finding the variance, the equation is sigma fd square divided by sigma f, and substitute the value. From this portion, we will get sigma fd square 130.198 divided by sigma f is 60, and the value comes to 2.1699, and that is how we find the compute the variance of the different questions. And now let's see what coefficient of variance is. Measures of dispersion means how far or how much the data are away from the mean. That is what is dispersion. The first tutorial itself I have mentioned about the measures of central tendency, how far each number in the data set vary or from the mean. That is known as measures of dispersion. So the standard deviation is actually an absolute measure of dispersion. Standard deviation is an absolute measure of dispersion, and the corresponding relative measure is known as the coefficient of variance. And it is used in questions, or it is used in distribution to find or to compare the consistency of data. This coefficient of variance is used to compare the variability of two or more than two series. And let's see what is coefficient of variance. Coefficient of variance, or CV, is equal to standard deviation divided by arithmetic mean. Standard deviation divided by arithmetic mean into 100. That is variance. Simply standard deviation by arithmetic mean into 100, and this is much more efficient in to compare the two distributions or efficiency. Let's see find how we can compare the consistency in the question which is given here, which shows the weight of two rats with the same feed for 10 months. And first this is to coefficient of variance is used to find the consistency and calculate which set of which rat is more consistent in performance with the feed. The question shows here, and the first step, of course, what you have to do is find the arithmetic mean. You have to compute the you have to make the table, find the arithmetic mean. So for here, after finding the arithmetic mean, I am just computing the coefficient of variance. Then coefficient of variance for the rat A and coefficient of variance for rat B. Arithmetic mean has to be computed. Arithmetic mean is equal to sigma n by, or arithmetic mean is equal to sigma x by n. Sigma x by n, and that is equal to 47. After that, you have to find the standard deviation. Standard deviation is equal to square root of sigma d square divided by n. And here, the standard deviation is 4.44. Then, the coefficient of variance, or CV, is equal to standard deviation divided by arithmetic mean into 100. That is equal to 9.44. So, coefficient of variance for the rat A is 9.44. Now, again you have to find the coefficient of variance, or CV, for rat B. And in this case, the arithmetic mean is equal to sigma x by n, and that is equal to 47.6. Then standard deviation is equal to sigma d square, square root of sigma d square divided by n, and the standard deviation for B is 4.15. And you have to compute the CV. CV is equal to standard deviation divided by arithmetic mean, 4.76 into 100, and the answer is 8.71. So for rat A, the value is coefficient of variance for rat A is equal to 9.44. Coefficient of variance for rat B is equal to 8.71. And in this question, now how to conclude the result? That is, you have to compare these two coefficient of variance and for which set the coefficient of variance is lesser the value of coefficient of variance, more consistent that data will be. So here the lesser value is 8.71. Of these two, the lesser one is 8.71, and so B is more consistent in performance with the feed. So here the coefficient, the answer is the rat B. That is how you conclude, because the coefficient of variance is less, it is more consistent in performance with the feed. So in this tutorial, I discuss about what coefficient of variance is, what variance is for the grouped and ungrouped data. Thank you for your listening.